Okay, let us carry on with ketones. Now they've got a more simple look to them because we only see a very clear peak for the C double bond O around 1700, and the peak, of course, for a CH bond. Again, to remind you of a simple ketone, propanone, it would look something like this. So we should see vibrations for C double bond O and CH groups. As I said in the previous video, this peak is very similar in ketones and, as you can see here, in carboxylic acids. So it's hard to distinguish these two if you just saw this one peak. Now, alkenes have a peak around 1600. Remember, alkenes have a double bond between carbons at 1600 here. And obviously the peak for CH. If we go back to the table, we can see that, which is starting to look a bit messy. The alkenes, 1600. Sometimes you see multiple bands for that. In our case, we only see one here, really. Okay, now what is the point of this technique? If you've seen part 1 and part 2, you should understand the basics. If you make something in the lab and you do not know what it is, you can always scan with an infrared machine, right? And you can check which bonds it has. That will give you a clue about the functional groups. Another way you could use it is to check whether some reaction you've done actually has gone to completion. For example, I'm going to use the skeletal diagram for now to make it a bit quicker. If we have a primary alcohol and we want to oxidize it, we reach a carboxylic acid if we use reflux and an oxidizing agent. Now, how can you know if this reaction has reached completion? You can scan at the beginning and see the peak for the OH group, and then scan again at the end once you've purified your product to see both an OH and the C double bond. So you can check if your reaction actually worked. Usually you see it with a color change in the oxidizer, but this gives you extra proof, and see if you have any impurities left. Now, if you get, let's say, an unknown sample, like the one we have here in the spectra, you can identify peaks. So the clear peaks here, once you've trained and you use the data table, you can see C double bond O and C double bond C. So in fact, this compound must have a carbonyl group. Carbonyl groups refer to any groups that have a C double bond O, and it also has an alkene. Now, if I scroll down, the compound, in fact, has an alkene group and an ester group, which is here. Now, again, it's hard to differentiate between esters, aldehydes, ketones, because they have a very similar band or peak. Okay, so hopefully you've understood how infrared spectroscopy works. Please comment below if you have any more questions that I can solve. Of course, I would like to acknowledge the different sources I've used, 2 different images and the data booklet, and most importantly, perhaps, this database, which you can check online, where I got all the infrared spectrum from. So there you can check different spectra of more complex molecules if you're interested. Thank you very much.